Let's solve few previous year questions. First question, this is the equation which is given, and it is told that it has real solutions for theta. Then what's the value of lambda? I mean, in which range that this lambda lies. So first, let's solve this equation. This can be written as cos square theta upon whole square plus sine square theta whole square plus lambda equal to 0. It's in the form of a square plus b square. So a plus b whole square minus 2ab, right? 2ab plus lambda is 0. So we know that this identity sine square theta plus cos square theta is 1. So from this lambda can be written as 2 sine square theta cos square theta minus 1. Now, if you see, it is 2 sine square theta cos square theta. What's the formula of sine 2 theta? It is 2 sine theta cos theta, right? So to get into this form, we need to multiply this term and divide the term by 2. So when you do that, we can write it as half of 2 sine theta cos theta whole square minus 1. This can be written as half of sine square 2 theta minus 1. And what's the range of sine square 2 theta? Range of sine square 2 theta. It is from theta belongs to 0 to 1, right? So if it is half of sine square 2 theta, then theta belongs to multiply half both sides. It becomes 0 to half. And if it is half sine square 2 theta minus 1, then theta belongs to, just subtract both with minus 1. It becomes minus 1. Half minus 1, it is minus half. So therefore, lambda belongs to minus 1 to minus half. So the required answer to this question is option B. In this question, we need to find the number of distinct solution of the equation which is given for you. This is the whole equation in the interval 0, 2 pi. Now first let's solve the equation. It is given as log, where half is in the base, mod sin x. If we transfer this log onto LHS side, it becomes plus log base half mod cos x equal to 2. Now, if you know the log properties, it becomes very simple to solve. It is log A plus log B, and bases are equal. It can be written as log of A into B. So it becomes mod sin x into cos x equal to 2. And when you convert log to the general terms, it becomes mod sin x cos x equal to half of whole power 2. This becomes to the power, this base comes here. Now this can be written as mod sin x cos x equal to half. Now we need to convert this sin x cos x into sin 2x. So to convert this, we need to multiply and divide it by 2. Next, we'll get it as 2 sin x cos x, which is nothing but sin 2x. And this is also will be in mod. And if we cancel this, it becomes half. Now, if we remove this mod symbol, it becomes sin 2x is equal to plus or minus half. Now, we need to find the solutions for this equation. So, we'll have again two cases. So, in case 1, it will be sin 2x is equal to half. And in case 2, sin 2x will be minus half. So in this equation, when will half come? It will be sine pi by 6. So it's in the form of sine theta equal to sine alpha, which is a simple t equation, which is a standard t equation. So this the general solution will be 2x, that is theta equal to n pi plus minus 1 whole power n alpha. Alpha is pi by 6. Then x will be n pi by 2 plus minus 1 whole power n pi by 12. Now similarly here, now this minus half can be written as sine 2x is equal to sine 5 pi by 6. It is nothing but pi minus pi by 6. I hope you know how to write this, right? So again, it's in the standard t equation of sine 2 alpha, sine theta equal to sine alpha. So theta, that is 2x, is equal to n pi plus minus 1 whole power n 5 pi by 6, and x becomes n pi by 2 plus minus 1 whole power n 5 pi by 12. Now we need to find the value of x such that it lies in the 0, 2 pi range. So keep n equal to 0 over here. It becomes x equal to pi by 12. If n is 1, it becomes pi by 2 plus, sorry, minus pi by 12. If n equal to 2, it becomes pi plus pi by 12. N equal to 3, 3 pi by 2 minus pi by 12. If n equal to 4, it becomes 2 pi plus pi by 12. Now, if you observe carefully, this value fits the range. It lies in 0, 2 pi. This also fits the range. This also lies in the range. This is also lies in the range. But this doesn't lie because it is 2 pi plus. But it should be, the range ends at 2 pi. So from here we can get the number of solutions are 4. Only from the case 1. But case 2 is still remaining. So let's see that. So if n is 0, x becomes 5 pi by 12. And if n is 1, it is pi by 2 minus 5 pi by 12. If n is 2, it is pi plus pi by 12. If n is 3, it is 3 pi by 2 minus 5 pi by 12. And if n is 4, it is 2 pi plus 5 pi by 12. Again, if you observe this, first 4, that which means this, and this fits the range, that is 0, 2 pi. But this doesn't fit the range because it is 2 pi plus, as range ends at 2 pi. Here from case 2, we'll get again the number of solutions are 4. So the total number of solutions, for this questions are 8. From here 4 and from here 4. So the required answer to this question, that is number of distinct solution, that is 8, is the required answer to this question. In this question, we need to find the number of solutions of equation, that is this, and x belongs to the range. And this is given in JEE in 2019, and 4 options are given, in which only one will be the correct answer to this question. So first, let's solve this equation. Let's simplify it. We can write it as 1 minus cos square 3x plus sine power 4x equal to 0. I'm just transferring this cos to the LHS side. Now 1 minus cos square theta is nothing but sine square theta, right? Sine square 3x plus sine power 4x is equal to 0. And now, if you observe, it is also a square number and it is also square ka square. So when this value will be equal to 0, when this is equal to 0 and this should also be equal to 0. When both terms are equal to 0, then only the RHS side will be 0. So the case 1 over here is sine square x. So case 1 is sine square 3x is equal to 0, and case 2 will be sine power 4x is 0. So from here we can write it as sine 3x is 0. So it's a simple t equation, that is sine theta equal to 0. Then the general solution will be theta, that is 3x equal to n pi. And we can write it as x is equal to n pi by 3. Similarly here, sine power 4x is 0, which is nothing but sine x is 0. And this is a simple t equation. So general solution will be x equal to n pi. So from here, let's find the solutions of this. So if n equal to 0, x will be pi by 3, 1, sorry, if n equal to minus 2, it becomes minus 2 pi by 3. If n is minus 1, minus pi by 3. If n is 0, it is 0. If n is 1, pi by 3. If n is 2, 2 pi by 3. If n is 3, it becomes 3 pi by 3, which is nothing but pi. And if you observe this range, it is something minus 5 pi by 2, which is here if you observe x belongs to minus 5 pi by 2 to plus 5 pi by 2. So this all comes in the range, and also if it is minus 3, again minus 3 pi by 3, which is nothing but minus pi, also comes in the range. 4 pi by 3 comes, 5 pi by 3 comes, 6 pi by 3 also comes, because it is 5 pi by 2, which is nothing but greater than 2 pi. Okay, so here it is just 2 pi, so it also belongs to the range. And the negative of all these three values also comes. Okay, that is minus 4 pi by 3, minus 5 pi by 3, and minus 2 pi. Okay, so here if you keep the value of n is 0, then x will be 0, 1, 0, pi, 2 pi. 3 pi can't come because it exceeds this range. Similarly, if you keep minus 1, it becomes minus pi. And if you keep 2, it becomes minus 2 pi. And minus 3 pi can't come because that also exceeds this range. So we need to find the intersection of these two values, because it should be, this term should be equal to 0 and this term should also be equal to 0. So we need to find the intersection of values. So let's see the common values from these two cases. That is 0 is common. Next, pi exists? Yes. Pi is also common. Next, minus pi also exists. Next, 2 pi also, and minus 2 pi. So these are the solutions which are common. So the number of solutions will be 5. Distinct solutions, right? So the answer to this question is option B. In this question, we need to find the number of values of alpha in the range 0, 2 pi for which this equation is true. Okay, so first let's simplify this equation. This can be written as 2 sine cube alpha minus 2. I'm just transferring to LHS, minus 7 sine square alpha plus 7 sine alpha equal to 0. So let's take common from here 2. Inside will be sine cube alpha minus 1. And here if we take minus 7 as common, it becomes, here we can take minus 7 sine alpha as common, and remaining part will be sine alpha minus 1 equal to 0. So use a cube minus b cube formula over here. You can write it as 2 a minus b, that is sine alpha minus 1 into a square sine square alpha plus b square plus 1 plus 2ab, that is 2, plus ab, that is sine alpha into 1. And this remains as it is, minus 7 alpha into sine alpha, 7 sine alpha into sine alpha minus 1 equal to 0. So from this 2, take sine alpha minus 1 as common. This can be written as sine alpha minus 1. Inside part will be multiply 2 with this part. It becomes 2 sine square alpha plus 2 sine alpha, and minus of this, minus multiply and minus of 7 sine alpha equal to 0. Now if we simplify the inside part, it becomes 2 sine square alpha minus this becomes minus 5 sine alpha plus 2 equal to 0. Just factorize this. We'll get it as 2 sine square alpha minus 4 sine alpha minus sine alpha plus 2 equal to 0. And this remains as it is, that is sine alpha minus 1. And from here, we can write it as sine alpha minus 1 into, take 2 sine alpha common from this, becomes inside it is sine alpha minus 2 minus 1 sine alpha minus 2 equal to 0. Now this can be written as sine alpha minus 1 into sine alpha minus 2, and remaining is 2 sine alpha minus 1 is 0. Now we have 3 equations, which means we have 3 cases now. Case 1 will be sine alpha minus 1 equal to 0. Case 2, sine alpha minus 2 equal to 0. And case 3, 2 sine alpha minus 1 is 0. So in the first case, it is sine alpha equal to 1, which is a simple t equation. So the general solution, that is alpha is equal to 4n plus 1 pi by 2, pi by 2, and n belongs to integers. And here sine alpha equal to 2, which is not possible because alpha range or the sine alpha range will be minus 1 to 1. Here sine alpha is half, which is nothing but sine pi by 6. So it's in the form of sine alpha, it's in the form of sine theta equal to sine alpha. So the general solution will be alpha equal to n pi plus minus 1 whole power n. Alpha, here alpha is pi by 6 and n belongs to all the integers. So here in the question, the range given as 0 comma 2 pi. So we need to find the value of alpha in that given range. So it is 0 comma 2 pi, right? So if we keep n as 0, it becomes pi by 2. If n is 1, it becomes 5 pi by 2. If n is 2, it becomes 9 pi by 2. But here only pi by 2 and 5 pi by 2 will be in the range. This exceeds the given range. And this is not at all possible. And here, if you see the values of alpha in the same range, that is 0 comma 2 pi, alpha will be, if n is 0, it becomes pi by 6. If n is 1, pi minus pi by 6 also exists in the range, and 2 pi plus pi by 6, no, it exceeds the range. So here also two solutions, that is pi by 6 and 5 pi by 6, this does not exist. This is a small change over here. 5 pi by 2 does not exist in the range, it exceeds the range. So the number of solutions will be 3. That is pi by 2 and here pi by 6 and 5 pi by 6. So the required answer to this question is option number C. In this question, it is given as A, B, C are the three non-zero real numbers such that the equation, which is this, is true and x belongs to the range minus pi by 2 to pi by 2, has two distinct roots alpha and beta. And alpha plus beta, the value is given, that is pi by 3, and we need to find the value of b by a. So first let's take this equation, that is root 3a cos x plus 2b sin x is equal to c. Here it is told that alpha and beta are the roots of this equation. So if alpha is a root, we can write it as root 3a cos alpha plus 2b sin alpha equal to c. And if beta is a root, we can write it as root 3a cos beta plus 2b sin beta equal to c. Now we can just eliminate this value of c, that is minus minus minus. When we do this, this gets cancelled, and here root 3a, if we take common, we'll get it as cos alpha minus cos beta, and here plus 2b, take it as common. Inside it will be sin alpha minus sin beta equal to 0. Now, this is in the form of cos c minus cos d. The formula is 2 minus 2 sin alpha plus beta by 2 into sin alpha minus beta by 2. Now this is in the form of sin c minus sin d. Now the formula for this is 2 cos alpha plus beta by 2 into sin alpha minus b by 2. So just substitute this formulas over here. You can write it as root 3a minus 2 sin alpha plus beta by 2 sin alpha minus beta by 2. I'm just taking this whole term on the RHS side, it becomes minus 2b sin c minus sin d, that is 2 cos alpha plus b by 2 sin alpha minus b by 2. Actually, here it will be sin c plus d because we are talking about c and d, right? So just change this correction. Here also it becomes c plus d. Here it is c minus d because we are talking about angle c and d. Now, if you observe, minus 2 and minus 2 gets cancelled, and sin alpha minus beta by 2 sin alpha minus beta by 2 gets cancelled. And substitute alpha plus beta equal to pi by 3, which is given in the question. It becomes root 3a sin pi by 3 by 2 equal to 2 cos alpha plus beta is pi by 3 by 2. So, and b is left over here into b. Root 3a sin pi by 6. Sin pi by 6 is half equal to 2b cos pi by 6 is root 3 by 2. So root 3 cancel, 2 and 2 gets cancelled. So from here we can find the value of b by a, which is nothing but half. So the required answer to this question is 1 by 2. In this question, we need to find the sum of all distinct solutions of the equation which is given in set S. Set S is nothing but here. In set S, all the values of x belongs to minus pi, comma pi exists. So we need to find the sum of all the solutions. So first let's simplify this equation. Convert the whole equation in terms of sine and cos. So it becomes root 3. Secant is 1 by cos plus cosecant is 1 by sine plus 2 tan is sine by cos, cot is minus cos by sine equal to 0. So take LCM, it becomes root 3 sin x plus cos x upon sin x into cos x. And here, take the LCM, it becomes sin square x minus cos square x upon sin x cos x equal to 0. So just eliminate this LCM. It becomes root 3 sin x plus cos x and equal to 2 of cos square x minus sin square x. I'm just transferring this term to the RHS. So just send this 2 term over here. It becomes root 3 by 2 sin x plus 1 by 2 cos x equal to cos square x minus sin square x. So if you observe over here, it is a sin x. This is now we need to convert this into some sin alpha and this into some cos alpha. And this is in the form of cos square theta minus sin square theta, which is nothing but cos 2 theta. Theta is nothing but x over here. So we can write this here, we can write it as sin root 3 by 2 is nothing but pi by 3 into sin x plus cos pi by 3 into cos x is equal to cos 2x. Now it's in the form of sin a sin b plus cos a cos b. So cos of a minus b, that is x minus pi by 3, is equal to cos 2x. So now it's in the form of cos theta equal to cos alpha. So the general solution will be x minus pi by 3 is equal to 2n pi plus or minus 2x. So we'll get two cases over here. Case 1, x minus pi by 3 will be 2n pi plus 2x. And case 2, x minus pi by 3 is equal to 2n pi minus 2x. So let's solve this. From here, if we simplify this equation, we'll get minus x is equal to 2n pi plus pi by 3. We can write it as x is equal to minus of 2n pi plus pi by 3. Now, if you keep the values of n, if n is 0, then x will be minus pi by 3. If n is 1, it will be minus of 2 pi and minus pi by 3. But here, what's the range of x? Here, the range is minus pi to pi. So this solution doesn't exist, only there's a one solution in this case. So let's solve the solutions for case 2. Here, if we simplify this equation, we'll get x is equal to 2n pi by 3 plus pi by 9. If n is 0, x will be pi by 9. If n is 1, it will be 2 pi by 3 plus pi by 9. If n is minus 1, it is minus 2 pi by 3 plus pi by 9. If n is 2, 4 pi by 3 plus pi by 9. But here in the question, it is told that x belongs to minus pi to pi. So this solution exists pi by 9 and 2 pi by 3 plus pi by 9 also exists. Minus 2 pi by 3 plus pi by 9 also exists. But this exceeds the range, which is something pi plus, right? So here there are three solutions, and in the case 1, it is one solution. But they didn't ask you the number of solutions. They told we need to find the sum of the all solutions of set S. So set S is nothing but all the solutions of x which satisfies. So it becomes minus pi by 3 from case 1, pi by 9, 2 pi by 3 plus pi by 9, minus 2 pi by 3 plus pi by 9. These are the three solutions from case 2. So if we add all these values, the sum of set S will be 0. If you add all these values, the sum will be 0. So required answer to this question is option C. In this question, we need to find the general value of x. General value is nothing but general solution of x satisfying the given equation. So first, let's simplify this equation. This can be written as sine square 2 power x whole square plus cos square 2x whole square is equal to sine 2x cos 2x. So it's in the form of a square plus b square. So this we can write it as a plus b whole square minus 2ab is equal to sine 2x into cos 2x. So this sine square theta plus cos square theta, it is 1 minus 2 sine square 2x cos square 2x is equal to sine 2x into cos 2x. So now to for the further simplification, just multiply 2 on both the sides, LHS and the RHS. So this becomes 2 sine theta cos theta. So it becomes 2 sine theta cos theta, which is nothing but sine 2 theta. So here, if you observe, again when you multiply this 2 with this term, it becomes 4 sine square theta cos square theta, which is nothing but 2 sine theta cos theta whole square, which is nothing but sine square 2 theta. So let's use this formulas and write the equation. 2 into 1, it's simply 2 minus, when you multiply this, I've given this, so it becomes sine square 2 theta, so it becomes 4x, because theta is 2x over here, is equal to sine 2 theta, that is sine 4x, because again theta is also 2x over here. So now you can see a quadratic equation. So just simplify this. So if we simplify this quadratic equation, we will get it as sine 4x plus 2 into sine 4x minus 1 is 0. So we can get two cases over here, that is sine 4x is equal to minus 2 or sine 4x is equal to 1. This case is not possible because sine theta cannot be minus 2 because the range of sine will be minus 1 to 1. Theta, that is 4x is equal to 4n plus 1 into pi by 2. So x will be 4n plus 1 into pi by 8. So this is the required general solution for the given question. In this question, we need to find the number of solutions of this equation in the given range of 0, 4 pi. So first let's take the equation, that is sine power 7x plus cos power 7 into x is equal to 1. So when this will be true, if you think properly, the power is an odd number. So there will be two cases. Case 1 will be sin x should be 1 and cos x should be 0. And case 2 is just the reverse of this. If sin x is 0, then cos x should be 1. Then only this equation satisfies. Only these are the two cases. So here sin x is equal to 1 and cos x is equal to 0. So for sin x is equal to 1, what will be the general solution for this? For this, x is equal to 4n plus 1 times of pi by 2, where n belongs to all the integers. Similarly, if cos x is 0, what will be the solutions? X will be 2n plus 1 times of pi by 2 where n belongs to all the integers. So now, as it is an AND, we need to take the common solutions from these two. So first, in the given range, 0 to 4 pi, let's write the solutions of these two separately. If n is 0, it will be pi by 2. If n is 1, it will be 5 pi by 2. If we keep n equal to 2, it comes out of this range. So these are only the only the two solutions which satisfy sin x is equal to 1 in this given range. So similarly, if you keep n equal to 0 over here, the solutions will be pi by 2. If n is 1, 3 pi by 2. If n is 2, 5 pi by 2. If n is 3, 7 pi by 2. If we keep n equal to 4, then it comes out of this range. So these are the only four possible solutions of cos x is equal to 0 in the given range. So if we take common solutions from these two, it is pi by 2 is a common and 5 pi by 2 is also common over here. So from the case 1, we got number of solutions are 2. That is pi by 2 and 5 pi by 2. So similarly, let's solve the case 2 over here. Again, take sin x is equal to 0 separately and cos x is equal to 1 separately. If sin x is 0, what's the general solution for this? X will be n pi where n belongs to all the integers. And if cos x is equal to 1, then x will be 2n pi where n belongs to all the integers. Again, in the given range 0, 4 pi, we need to find the solution separately. So if n is 0, it is 0. If n is 1, pi. N is 2, 2 pi. N is 3, 3 pi. If n is 4, 4 pi. We can't keep n equal to 5 because it just comes out of this range. So these are the 5 solution for sin x is equal to 0. Similarly, if we keep n equal to 0 over here, it becomes 0. If n is 1, 2 pi. If n is 2, 4 pi. Next, it just comes out of the range. So these are only the three solutions for the cos x is equal to 1. So now, as it is and over here, we need to take the common solution from these two. That is, 0 is common. Next, 2 pi is common. Next, 4 pi is common. So here, the number of common solutions are 3. That is 0, 2 pi and 4 pi. So now total number of solutions will be 2 plus 3, that is 5. So in the given question, C option is the required answer to this question.